Let's look into this problem of J 2020. Let A and B be positive real numbers. A is bigger than 1, B is lesser than A. P is a point in the first quadrant that lie on the hyperbola. So let us first draw a rough sketch of a hyperbola in order to have an idea of this question. Somewhat like this would be the hyperbola. And if I look at this way, they say that the tangent at any point P in the first quadrant passes through point 1, 0. So if I take this point as P, the tangent passes through the point 1, 0. I don't even need the parametric coordinates because I don't see much of work here because it's more about the area. Suppose the tangent passes through, so the normal at hyperbola cuts off equal intercepts. So this would be the normal to the hyperbola passing through P and cuts off equal intercepts on the coordinate axes. Delta denotes the area of the triangle formed by the tangent at P, the normal at P and the axis of X. So essentially this is the triangle whose area is in question to be tackled with. So let us shade this for ourselves. Now the question says, if E denotes the centricity, which of the following options are true? I take this point as x1, y1. So the tangent has an equation x1 upon a square minus y1 upon b square is equal to 1. And since this passes through 1, 0, so the moment I satisfy 1, 0, I get x1 as a square. First job done. Second, since this line normal is equally inclined to the coordinate axis, has equal intercepts and is in the first quadrant, so obviously the slope comes out to be -1. If this has a slope -1, so the tangent definitely would have a slope +1. If the tangent has slope +1, I compare this slope with the slope of this tangent. The slope is basically b square over a square times x1 upon y1, and this is equal to 1. x1 is a square, so this implies that y1 is b square. More so, the point x1, y1 has to lie on the hyperbola, so should satisfy the equation when you put x as a square, so a raised to 4 upon a square, that is a square, minus b raised to 4 upon b square, that is b square, should have been equal to 1. This is your condition that you will use. You have 4 options, 2 talking about the centricity and 2 talking about the area of the triangle. Let us first look at the area of the triangle. We will use that it is half base into altitude. Altitude is nothing but the length y1. y1 net is nothing but b square. Now what is this length? So if I take the equation of normal, this is basically x plus y is equal to some lambda because the slope is -1. And since the point is passing through x1, y1, which is a square, b square, so lambda is nothing but a square plus b square, that is the equation of the normal. When this particular normal meets the x-axis, we put y is equal to 0. So this point is a square plus b square, 0, and this point is 1, 0. So your base is a square plus b square minus 1. A square minus 1 is b square plus b square is 2b square, so your delta is b raised to 4. So out of C and D, you know that D is done. Now coming to the eccentricity, how do we know? So we know that eccentricity E square is 1 plus b square by a square in this case. So I divide this entire equation by a square, so I get 1 minus b square by a square is 1 by a square. If I swap this on this side and add on 1 on both sides, I get 2 minus 1 upon a square is your e square. This in itself is sufficient to say that e square, which of course is bigger than 1 because this is an hyperbola, but simultaneously if I look at this, then e square because of this can be written as 2 minus, I will take this space, use this space, 2 minus e square is equal to 1 upon a square. 1 upon a square is all the time greater than equal to 0. So e square is all the time less than equal to 2. So e is less than root 2. So I get my option A as the other one correct.